you say that if you once you understood the basics of how to do that, then you could go in and mix and match accordingly? I mean, you were telling me a moment ago that some of the books that you have on this topic are
you can get really out there.
Are like really, really thick books.
Yeah.
Okay. Okay. So you're it's just like all things. If you're at that point where you have snapped all the Lego pieces together, and at some point you're like, man, I really wish I could X, Y, Z, then you're probably at that point where you might need to investigate shaders.
Right.
Okay. Well, I wanted to point out this other piece of this article here was that there was web-based shader playground, which I know you're going to talk some about that here in just a moment. Hey, Ed, can you send Sergey the link to the Hangout? He just popped in and...
I can do that.
Yeah, thank you, sir. I know you're going to show us some playground stuff as well, but I think it's one of those things that people don't really realize are there. But it's kind of a cool little thing to be able to do stuff sort of interactively. And then the other thing I wanted to point out, and this is just sort of, again, just sort of background stuff before we get to the more in-depth technical pieces. There is a guide that is out there. It's called the Shader Effects Guide. And this actually gives a nice little breakdown. As I was reading through this, do you have any thoughts or comments here, Stephen? I mean, does any of this match what you were going to...
I would definitely recommend reading this.
Okay.
I'll cover bits and pieces of it, but I won't refer to it in...
Okay. Well, I just like the, I like the visual representation here where it was kind of breaking up the process, talking about, GPUs and being able to, because again, you were talking about this being programmatic, being basically writing a program to do things. So I thought that was kind of interesting. So that's as you can tell, it's very in depth. There's a lot of material there. So definitely recommend that. We'll put a link in the show notes to it so everybody can kind of follow along there. And then we'll put a link to the docs for filters, generators, and composites. So the interesting thing I think about filters, generators, and composites was that what was it? Was generators seemed to be sort of a like you were saying, programmatic, like you're creating. You're not manipulating the image. You're actually writing a program to create something.
It's a pure effect. Yeah.
So you don't really have any source material. You're just writing code to generate the end result.
Yeah.
Filter was you have something.
You transform a texture.
Okay, good. So transform a texture. So you have
filter the texture.
So you have an image and you're manipulating the image.
Mm-hmm.
All right, and then composite was what? I mean, that's what's that?
Two textures.
Taking multiple things and smashing them together.
Yeah.
Yeah. Okay. So, with that kind of knowledge in mind, multipass shaders. What is that about?
Okay, I won't be incorporating this into my material, but this is where you can take one shader, run it, so generate the result, and then feed that result into the next shader. So you can serialize several. You can put several shaders in a row and feed one's output into the next one as an input. So
okay,
you could blur the screen with one of them, and then wave it with the next one, and then switch the color on the next one, and the effects would combine.
Gotcha. So you could kind of build on different effects and then smash them together and then get a completely different result. Well, that's okay. That sounds like a fairly advanced topic as well. So, but
that's probably the most common use. There's a few others, like you can break apart things with heavy loops in them by doing a few loops per pass, and it's easier on the graphics card that way in some cases.
Okay.
Okay.
Okay. Well, before we move on, does anybody have any questions or anything that they want to ask, or anything they want to baseline before we go? Because I mean, I'm just trying to ask sort of the general things, but I don't think.
When I was playing with the shaders, I saw the y-axis is inverted in the web playground and in the actual Corona. Is it still the case, or was this missing something?
I think it's I'd have to double check this myself, but I believe it's inverted in both because
Okay.
WebGL and OpenGLES are meant to be almost the same. The shader languages are anyway.
And when you say, so yeah, that's a good point right there. So shader languages, this is not specific to Corona. I mean, for the people who are new to the topic of shaders, this is something that's...
This is a flavor of OpenGL called OpenGLES, which is embedded systems. So it's basically for mobile devices. And WebGL is what's used on the web. And they're almost the same, these languages. There's also desktop GL. And I think the simulator uses that. So there are slight differences if you move from simulator to device. Not many, but they're there.
Even within Corona, is that what you're saying?
Yeah.
Okay.
And then there's other languages. There's CG, which is sort of an in-between layer that generates shader language for you. It's from NVIDIA. And there's HLSL, which is on DirectX. It's high-level shader language.
Okay.
It's a lot alike. So you can move from one to another fairly easily.
Did you say it was a lot of lighting?
They're a lot alike.
Oh, a lot of like. Okay. I was like, wow, you have to know about lighting as well?
You can get into it, but you don't need to.
Okay. Well, what kind of material do you have for us?
Okay, I'm going to start with the playground. So let me share my...
And so for people who don't know, there's we'll put a link in the show notes, but you can go and actually put your stuff in an online editor, I guess, of sorts, and you can see the end result, kind of like Swift does Playgrounds, where you can just sort of play with snippets of code and not have to write a whole program, even though, as Stephen has described it, these are programs. And then you can take that and you can share it. So you can send that link to somebody and say, hey, look, this is how this piece of code works, and this is the end result, which is kind of cool. I wish we had a library of these things, right? Like you can generate a little Google short link and you can send it to somebody, but I would like to see a running list of these things. That way you could, so it'd be more discoverable.
There's a thread in the forums that kind of does that, but it's been up for easily over a month now, and it might have gotten a little long-winded. It's not like a compiled list, but there are a few forum posts that I think people have been, putting links. I think Sergey has a couple of links. I think Steve does too.
Yeah. It would just be good to be able to, I don't know, even if it was searchable, right? Like I'm looking for, something this keyword, and boop, oh, look at there, that's an interesting example. I'll use that.
Yeah, there is a shader tag in the Code Exchange as well.
Okay.
All right. So let's see. Do you see this blue, the square?
Yeah, we do.
Okay. So this is the playground. It's at this link, and you probably noticed right off the bat that this isn't Lua.
Yeah, that doesn't look familiar to Lua.
Okay. This is GLSL. If anyone has ever used C, it's a lot like C.
Okay.
It's this. If you go to this link, you get there's a chart with everything in the language. It's very concise, but everything we'll be using is in here.
Okay, I'll put a link in that in the show notes because it's So for those listening, it's a fairly in-depth chart on what's the chart about?
The first half is about OpenGLES itself, but you really don't need to know that for Corona. The second half is the language itself, the functions that are built in.
Well, it's kind of a cheat sheet, though, right? It's like a condensed version.
Yeah, because you'll have it all in front of you then. And so you need semicolons in this language. Unlike Lua, you need to declare your types. You need to declare a specifier, which is the precision. In some devices, precision supposedly can improve your speed. If you have lower precision, it'll take less bandwidth, so you can move points through faster. But for this, I won't be dwelling too much on that.
Okay. When you say precision, though, I mean, like we talk about, I don't know, and types in other language like floats and doubles.
The size of a number,
Mm-hmm.
basically, that you can stuff into a variable, or how precise, how much your floating points, your numbers between integers. How
You're
accurate?
talking about the size of the representation, correct?
Correct.
For precision. When you choose a precision, you're saying are you going to use 32 bits or 64 bits?
Right. You have in GLE